and we're going to go over them. A yawn is a demerit, so don't even think about it. And yeah, don't think about it, because if I yawn, that's going to be 2 demerits then. All right, so here we go. Yeah, now I want to. All right, here we go. Example 1. The radius of a circle is increasing at a constant rate of 8 feet per minute. So that is what? Yeah, dRdt. So put 8 feet per minute. I guess you don't have to put the units because all the units are going to match anyways, but it'd be nice if you did. At the instant when the radius of the circle is 7 feet, so when the radius is 7 feet, so put 7 feet, what is the rate of change of the area? So here we go. Do you know area of a circle? Area of a circle is pi r squared. Now, later on, when you take the UH quiz, it's going to say to take the derivative of area with respect to radius. Right now, we're just taking the derivative of area with respect to time. So here we go. I'm going to take the derivative. So dA dt is equal to 2 pi r dr dt. Are we still okay? Did we do anything crazy? No. All we're going to do is just plug in, guys. 2 pi times the radius, which is 7, times the dr dt, which is 8. You take your calculator and you put all those values in. 2 times pi times 7 times 8. So here's my calculator. 2 times pi times 7 times 8. And we get 351.858. And if you know the units, it'd be nice if you put the units square feet per minute. That was a pretty straightforward. That's a demerit right there. You got one. I'm just kidding, YouTube. Yeah, I know. My bad. Yeah, next time everyone gets a Red Bull. Okay. Yeah. Oh, what are we gonna do tomorrow? Tacos? All right. Hey, don't spread. I'm just gonna get an X amount of tacos, and that's it. Everyone gets a taco.
What kind of taco?
I'm just gonna buy 20 bean and cheese and call it a day. And so that's enough for you guys, and one each for you guys, and one for the BCers. All right. No, second period. No one. I'm gonna stick them in the closet, and then second period we'll take them out.
Man, I don't like this.
All right, here we go. Example 2. The height of a cone is increasing at a constant rate of 8 feet per minute. So the height of the cone, so right on the side, dH dt, 8 feet per minute. The volume remains constant, 178 cubic feet. So volume equals 178 cubic feet. And since it remains constant, that means that dV dt equals 0. At the instant when the radius of the cone is 4 feet, so when r equals 4 feet, what is the rate of change of the radius? So they want dr dt. Question mark. Sometimes I need the height, sometimes I don't need it. I'm going to go ahead and figure out what the height is. Maybe I need it, maybe I don't. Well, actually, it depends. It depends on how you do it, because sometimes you don't. I'll do it both ways so you can see what I'm talking about. Because actually, when I can see that when, okay, let's just do it. What's my volume? 178? So I'm going to find H. 178 equals pi over 3. What's my radius? 4 squared H. My volume's not changing. It says right here. I'll underline it for you. The volume remains constant. Underline remains constant.
So when it says remains constant,
Yeah, because it's not moving. It's not increasing or decreasing. Does that make sense? Okay. All right, here we go, guys. So go 170. I'm going to go ahead and multiply this by 3. So 178 times 3 equals 16 pi with the h on it. And then to get h by itself, I'm just going to go divide by 16 pi. So 178 times 3 divided by 16 pi. Whatever that is, let's see what that is. Take your calculator. And I'm going to go 178 divided by, open parenthesis because the calculator is dumb, and I'm going to put 16 pi in parentheses. You can also use the fraction feature, but tell the calculator to give you a decimal. And I'm going to push enter. And you see this number, 3.5411? I'm going to store that in the calculator as a register, 5411. I'm going to store that to A. So I'm going to put an arrow, and I'm going to call it A. Radian.
I don't think he multiplied by 10.
Oh, yeah. All right. Yeah. I see it. Let me do it again. All right, guys, hold on. 178 times 3 divided by 16 pi. Oh, and now I didn't put parentheses, so I would get another error. Second, insert parenthesis, and close it right here. Okay, there we go. Now I'll get it right. 10.623. Did everyone get that? 10.623, and I'm going to store it to A. How do I do that? I just go on the calculator. I'm going to push stow alpha A. Enter. I just go down the alphabet. Are we okay so far? So now everyone knows that my height is stored in A. All right, here we go. Volume equals pi over 3 r squared h. Here's how I want to do it. Delta doesn't do it this way. Delta goes ahead and does the product rule with the dVdt in there. I know that the volume is constant. If I know that the volume is constant, I don't need to do the product. I can just move, let's see, what do I want? I want dRdt. I can just move so I'm going to multiply by 3. So I'm going to say 3v equals pi r squared h. Do you guys see what I did there? And I'm going to divide by pi h. I'm going to divide by pi h. So here, let me show you what the constant. 3v over pi is a constant, and I'm going to move this h up. H to the negative 1 equals r squared. Do you guys see what I did? All right, I'm going to take a derivative. This that I'm circling is a constant. So there's no need to do product rule, or, if you wanted to do product rule with a v there, there's no need. It's a constant. Delta doesn't do this. Delta just takes the derivative with the constant from the very beginning there. So here we go. I'm taking the derivative. Negative 3v over pi h to the negative 2, but I'm taking the derivative with respect to what? Time. So put a dHdt there, guys. Are we okay with that? Equals 2r dr dt. Yay or nay? Have I confused anyone? Here comes algebra, and it's not a crazy algebra, guys. Negative 3v over pi h squared, the h dt, equals 2r dr dt. I just went ahead and rewrote it. I'm going to start plugging in numbers. Negative 3 times my v, which is 178, divided by pi, parenthesis, the h was saved as 10.623. I'm going to put a. So that's the number saved in my calculator. I'm going to square that, and I'm going to multiply that sucker by dHdt, which was 8. And all that equals 2 times, what's my r? 4 dr dt. Really, isn't 4 times 2 8? Yeah. I can just cancel that 8 and that 8. So there it is. My dr dt equals, and let's see, I'm going to take my calculator, and I'm going to use the alpha fraction feature. And I'm going to go negative 3 times, what was it? 178, close it, parenthesis, and then it was pi, so put the pi in there. And then alpha a, and was it a squared? And I'm going to push enter. Oh, okay. You see? No, I canceled it. You see this fraction here? Yeah, you can go ahead and just type it in like this, but I'll show you how to tell the calculator to always give you a decimal. And I'll show you that right now in a little bit. 8550. And there it is. Is that the same number that they have up there as the answer? We got it, guys. Negative 1.506. And I'll show you how to tell the calculator to always give you that. Negative 1.506. Let's put more digits just because we can. 0818. 0818. And the units are feet per minute. Okay. Here's how you can tell the calculator to always give you a decimal. If you go to mode and you just go down, let's see, where are you, buddy? You see where it says answers? It says auto and DEC. Just push DEC. And now no matter what, it'll always look, it won't give me a fraction anymore if I do this. Enter, boom. See? I just push mode. Mode tells me like what I want the calculator to do. And I went to answers and I put DEC, which stands for decimal. All right, how do we feel, guys? Okay, yeah, let's go to the next one. Vamos para la otra pregunta. I bet you didn't know I could speak Spanish. Oh, I did? I don't remember. Oh, okay. Kanilong, Kanyulan Yusan. I bet you didn't know I could do. Okay, I'll stop. That was gibberish. All right, here we go. Ready, miss? The radius of a cone is increasing at a constant rate of 6 centimeters per minute. What is that? So I'll put 6 centimeters per minute. I like to see the units. And the volume is decreasing at a rate of 22 cubic centimeters per minute. What is that? So put dVdt equals, it's decreasing, so what do I put? Negative 22 cubic centimeters, so centimeters cubed over minute. Are we okay so far? Nothing crazy, right? Okay. At the instant when the height of the cone is 2 centimeters, so put height equals 2 centimeters, and the volume is 146 cubic centimeters, so volume equals 146 cubic centimeters. What is the rate of change of the height? So they want the HDT, question mark. Are you guys ready? First, find R. Put that down as the first step. First, find R. So we're just finding R, guys. They don't give it to you. I mean, they kind of give it to you, but not directly. So I'm going to insert 146 equals pi over 3. And then I don't know what R is, so I just put R squared. And then the H is 2. Are we still okay? I make it pretty. I guess you can go right into solving right off the bat, but I like to make it pretty. 146 equals 2 pi over 3 R squared. Are we okay?
Oh, I got
Okay.
it.
All right. Well, I just multiplied. But okay. Cool. I'm going to get rid of the 2 pi over 3. Yes, you can say divide, but I like to say multiply by the reciprocal. 3 over 2 pi, that cancels out. Whatever you do to one side, you do to the other. 3 over 2 pi, I don't know what that number is, so I'm just going to leave it like that. I'm going to go 3 times 146. Come on, buddy. 146. All over 2 pi. I'm going to use that fraction feature in a little bit. That equals R squared. Are we still okay? Square root. Square root. Square root. And then whatever answer that is, I'm going to type into my calculator and store it in a register. Well, that's what those letters mean. Store it in a letter. So here we go. I take my little calculator. I put, let me clear this. Second square root. I push alpha y equals, enter, so I don't make any mistakes. There's my little fraction. And I already forgot. What was it? 3 times 146. 3 times 146 in the top. And the bottom, what do I put? 2 pi. And then I push enter. And let's see what I get. 8.349. 8.349. I'm going to store this, so I'm going to put an arrow. And I like to just go down the alphabet. If you want to store it to R, you can. So how do I store it? I push what? Store alpha A. Start using technology, guys. That's going to store all those digits. All of them. Cool or not cool? Okay, there you go. So now, Here we go. I'm gonna store that to A. So everywhere you see a capital A, that's what I'm putting in. So I'm gonna go back to this guy right here. And now I'm gonna take a derivative. Do I got a lot of space? Heck yeah, I do. I did that on purpose. Volume equals pi over 3 r squared h. I'm just gonna go ahead and take a derivative right off the bat. I'm not gonna pair the pi over 3, guys. I'm gonna do it like this. Because I think it's easier, I think. For not always, but in this situation, I think it's easier. So here we go. I'm going to take a derivative. dv dt equals, leave that constant alone. Put a bracket first. So I'm going to put parentheses. R squared times the derivative of the second. What's the derivative of h? dh dt plus second. H times the derivative of the first. 2r dr dt. Close bracket. And I am ready. I'm just going to solve for dh dt. I'm not going to isolate. I'm just going to plug. I'm going to plug in immediately. So here we go. My dv dt was what? So I put negative 22 equals pi over 3 bracket. What was my r again? Let me zoom out so I can see. My r was a, so I'm going to put a squared on the inside like that. And then I don't know what dh dt is, so I'll put dh dt plus h, which was 2. And then times 2 times a times dr dt, which is 6. And I'm just going to type it in like that. So let's see. I'm going to go ahead and multiply by that 3 over pi, guys. Negative 22. Negative 22 times 3 over pi. That's because I'm doing this. I go times 3 over pi. Yeah, so times 3 over pi. In case you're wondering what I'm doing there. Equals, and then I'm just going to add this up right here. Well, actually, no. I'm going to subtract. You know what? Erase that equals. I'm gonna write that. Minus 2 times 2 is 4. 4 times 6 is 24. Did I do that right? 6 times 4. 24a equals a squared dh dt. Oh, this is going to be even pretty. This is going to be so pretty. Yeah, look how pretty this is. I'm just going to go right to the answer here. dh dt equals, check this out. How am I going to type this in the calculator? Be smart. I'm going to type this on the left first. I'm going to push enter, and then I'm going to divide by a squared. So look, check it out. I'm going to put the little fraction just like that. What did I have? Negative 22. Negative 22 times 3. So I guess I could have done that by hand because that's not hard to do. Over what? Pi. So we'll put the pi in here. And then look, minus, I put 24a right there. So I'm just going to type it in like that. 24. I did save it to a, right? Yeah, I did. 24a. And I'm going to push enter. Look at that, guys. Look how beautiful this is. See that answer? What do you think I'm going to divide that by? A squared. Divide by, I'm going to put it in parentheses just in case I get an error. Put the a squared inside like that. And then close it. And then enter. And is that what it says for answer? There it is. Negative 3.17588. 3.17588. Yep. 176. Yep. Good job. Why did I say good job to myself? Sorry. I use the minus sign. Because if you use the negative, then it's going to be like multiplying by 24. Negative 24. What happened, Wilson? I know. Go take a little break, guys, if you feel like you feel tired. All right. How do we feel, guys? Okay. I know I told you guys that I was going to solve example 2 another way, and I never came back to it. So maybe if you guys have time, we'll do example 2 a different way. All right, go to example 4. These get kind of easy. So we kind of already did the hardest questions, guys. These get kind of easy. You think Alvarez is watching this video right now, right here? Well, not right now, but later on. Hey, Wilson says what's up, Alvarez. Oh yeah, she loves Angie math. So if it's real, you're gonna tell Wilson that she's so awesome because she loves Angie math. Okay, I'll stop. I'll stop. Here we go. Should I delete that? Oh, okay. I'll keep it. All right. Here we go. Here we go. A rectangle has the length of 5 inches and a width of 6 inches. So I have a rectangle. I mean, I guess you don't have to draw it. So this is my length. Here's my width. It's not drawn to scale because it says that my length is 5 and my width is 6, and it looks like the length is bigger. No big deal. So here we go. Length equals 5. Width equals 6. And we're talking about inches. Whose sides are changing. Okay, so they're changing in size. The length is increasing by 4 inches per second. So that means what? So 4 inches per second. And the width is growing at 5 inches per second. So what is that? Yep. And what did it say? 5? 5 inches per second. Okay. What is the rate of change of the perimeter? Well, guys, we should know what perimeter is. Perimeter is 2L plus 2W. I don't know why I said it like that. I'm sorry. Cool or not cool? Right, here we go. Let's take a derivative. dp dt is equal to 2 dl dt plus 2 dw dt. Yay or nay? You cannot cancel those twos, so don't even think about it. Don't cancel because there's not a 2 in the 2 dp dt. And I can't even say the words right here. Tongue twister. All right, here we go. They want dp dt, so I'm just going to plug in. This is what's called plug and chug. 2 times, what's dl dt? 4 plus 2 times, what's dw dt? Yeah, no, this really is what's called plug and chug. You just plug in and you get your answer. So here it is. 2 times 4 is 8. 2 times 5 is 10. What's 8 plus 10? So there it is. So dp dt is equal to 18 inches per second. If you look at the units, it all makes sense. Cool or not cool? Cool. Yeah, they're all easy. Miss, this wasn't hard. It was just cumbersome, but it wasn't hard. But it's not hard. You can do it. It's just little steps, several little steps. All right. Here we go. Here we go. Next question, guys. A rectangle has the length of 5 inches and a width of 8 inches. So let's write that down. What's the length? 5 inches. What's the width? 8 inches. Whose sides are changing. So you know they're either growing or getting smaller. The length is increasing by 4 inches per second. So that is what? dl dt equals 4 inches per second. And the width is shrinking at 9 inches per second. So what is that? dw dt, and it's negative 9 inches per second. Good job. What is the rate of change of the area? Well, how do I get area of a rectangle? So write that down. Area equals length times width. So what rule do I got to use here? Product. So here we go. dA dt is equal to first, so L, times the root of the second, dw dt, plus the second, W, times the root of the first, which is plug and chug. No, that is a real thing, by the way. So L is 5 times dw dt, which is negative 9, plus W, which is 8, times dl dt, which is 4. So let's see, 9 times 5, what's that? Negative 45, plus 8 times 4, 8, 16, 32. And the difference, 32, 42, 43, 45, negative 13. And the units, square inches per second. Cool or not cool? Okay, let's go to these. Now, here we go with these again. Don't worry. What was that look like? All right, here we go. The area of a square is increasing at a rate of 108 square inches per second. So I have a square, and it looks like it's getting bigger then. So the area of a square is increasing. So what is that? 108. So dA dt is equal to 108 square inches per second. So write that down. At the time when the area of the square is 36 inches, so that's A equals 36 inches. What is the rate of change of the perimeter of the square? Okay, so they want dP dt. Question mark. Before you can solve this, you need to figure out what the length of each side is. Do you want to call it S or do you want to call it X? It doesn't matter to me. S. So S stands for side. So area is equal to side squared. Yes or no? They told me that the area is 36, so you're going to go 36 equals side squared. So that means square root. S is equal to what? There you go. You got everything you need now. Are we okay so far? All right, here we go. The perimeter is 4S. Oh, it looks like we didn't need it after all. We're going to take a derivative. But sometimes you do need it. You'll see in a little bit. I'm going to take a derivative of this. Here we go. dP dt is equal to 4. What did I put on the side? Oh, but I do need a ds dt. Do I have a ds dt? No. So here's how you're going to get it, guys. Here's how you're going to get it. Remember they told us that dA dt was 108? So let's take a derivative of this guy right here because you need that 6 anyways. So here we go. dA dt is equal to 2s ds dt. Are we cool right now? Oh, we're not cool? Okay. Plug that dA dt in. What happened? I don't know how I did that. Oh, there it is. It just fast forwarded it. 108 equals 2 times 6 ds dt. We're solving for ds dt, guys. So 2 times 6 is 12. So ds dt is equal to 108 divided by 12. That's some number. It's 9? Perfect. Use that number to plug it in there. So dP dt is equal to, what's 9 times 4? 36, and my units are inches per second. How do we feel? All right. Let's go to the next one, guys. All right, we're going to go slow. Is this the last one? Oh, we just got 3 more, but they're all simple. All right. The volume of a cube is decreasing at a constant rate of 427 cubic feet per minute. What's that? dV dt equals, and it's decreasing, so what's that? Cubic feet per minute. Are we still okay? At the instant when the side of the length of the cube is 5 feet, so that means at the instant when the side length of the cube, so S, when S is 5. Oh, because it's a cube. So a cube has all sides the same. Yeah, a cube looks like, yeah, all right, I'll draw it right here.
So if it was a rectangular prism.
My cube doesn't look perfect, but yeah. All right, here we go, guys. At the instant when the side length of the cube is 5 feet, what is the rate of change of the surface area? Do you know what the surface area is of a cube? It's basic geometry. It's not extreme. How many faces? Well, okay, yes. How many faces does a cube have? And each face has an area of s squared. So it's 6s squared. You got to know basics. Just basics. Not anything extreme, guys. Just basic. Are we cool? All right. Let's see. What do we got to get first? Okay, we need dsdt, but we don't have it, but we have volume. All right, here's how okay, write this down. Put, we need ds dt. Get ds dt from, get ds dt from dv dt, from volume. From v equals s cubed. We're going to take a derivative. Are we cool? So here we go. dv dt equals, what's the derivative of s cubed?
3s squared ds dt.
Perfect. I already know what dv dt is, guys. It's negative 427. So negative 427 equals 3 times 5 squared ds dt. 5 squared is 25, and 25 times 3 is 75. So ds dt is equal to, okay, I'm slowing down. ds dt is equal to negative 427 divided by 75, which is some number. Let me see. Negative 427 divided by 75. Okay, it is actually a fraction that you can make nice and pretty, but I'm just going to store it into a letter. Store alpha A. Negative 5.693. I'm gonna store this to A. Are we okay so far? All right, here we go. What did I want again? dAdt. So here we go. I'm gonna take a derivative of this guy right here. So whatever's in sky blue is my next step. So I'm gonna write dAdt is equal to 12s ds dt. I already know that s is 5. So 12 times 5 times my ds dt, which was A. So let's see. It's this 8. Let's see what we get. 12 times 5 is 60. 60 times A. So I already have it here. 60A. Yeah, it should be pretty. Yeah. Negative 341.6. Is that what it says for the answer? And I need units. Square feet per minute. Oh, that's how you say it, square feet. Don't say feet squared. It's okay. Cool or not cool? What's up, Gian? I'm sorry, I didn't hear it at all.
Oh, why did you store negative 5 as A?
Oh, negative 5.693 with the 3 repeating forever. I could have just made it into a fraction, but I just wanted to store it. Just so you can see that you can use the fancy features of the calculator. All right, guys. Oh, I just don't want to. You don't want to round until the very end. You don't want to round. So, yeah, if you just start writing 0.693, it might be off. Look, if I would have gone negative 5, let's see if it would have gone right. 0.693 times 60. Let's see how close we are to the real thing. Look, it's off. If you would have typed negative 341.580, it would have counted it wrong.
Yeah, no, but where does that 8 fit into
It doesn't. Like, I just made it up. I just went down the alphabet into A. So D. Well, this is dsdt. Okay, this is dsdt. So I'm plugging it into dsdt. Yeah. So 12 times 5 times A, which is dsdt. You know what I mean? Okay. How do we feel, guys? Do we feel okay? Okay, we got 2 more. So here we go. This is an excerpt from the related rates triangles, and these are the last 2, and then that's it. We should be good to go. A right triangle has legs of 12 inches and 16 inches whose sides are changing. So this is a right triangle. So I'm going to call this A, I'm going to call this B, I'm going to call that C. A squared plus B squared equals C squared. The short leg is decreasing, so the short leg has to be the smaller one. So A equals 12, B equals 16, and they're both inches. Are we okay? I haven't done anything yet, guys. I haven't done anything yet. The short leg is decreasing by 4 inches. Which one's the short leg, A or B? A. So write dA dt And I'm decreasing by 4 inches per second, so I put what? Perfect. Negative 4 inches per second. And the long leg is shrinking at 7 inches per second. So what do I write? Negative. Perfect. What is the rate of change of the area? I love it. I don't understand. Did I say it weird?
All I heard was I love it.
I wasn't trying to be silly, but okay. I wasn't trying to be silly, but okay. The area of a triangle is 1/2 AD. Man, guys, this wasn't McDonald's or anything. Like, I'm loving it, you know. Like, okay. What rule am I gonna use right here? Product. I'm gonna group the 1/2 with the A. This time I'm gonna group it because the 1/2 is not like a pie that makes stuff complicated. So here we go. dA dt is equal to first 1/2 A times derivative of the second dB dt plus second B times derivative of the first 1/2 dA dt. You got everything, so we're just going to plug and chug. 1/2 times 12, and then dB dt was -7, plus the B was 16, times 1/2 times dA dt, which is -4. All right, let's see. Half of 12 is 6. 6 times -7, that's -42. Half of 4 is -2. 16 times -2 is -32. 42, 52, 62, 72, 74. -74 square inches per second.
Well, you wrote it as -42 plus.
Oh, I said -32, but I didn't write it in.
I was like, wait a minute. I was
Yeah.
-42 plus 30.
I said -32, but I didn't write the -32. Are we okay, guys?
Yep.
One last one. Here we go.
Another right triangle.
Yeah, because this is the right triangle one. A right triangle has legs of 30 inches by 40 inches whose sides are changing. So that means the sides are getting either bigger or smaller. So I'm gonna write a right triangle here. A, B, C. The short leg is increasing. Okay, well I guess I gotta write first what A it is. A is 30, B is 40. The short leg is increasing by 8 inches per second. So that is which one? The ADT, 8 inches per second. Inches. And the long leg is shrinking at 2 inches per second. So that is the PDT, -2. What is the rate of change of the hypotenuse? Okay, before you can solve for this one, you actually got to solve for C this time. But it's a simple one. It's a 3, 4, 5 triangle. So C is just 50. Yeah, it's a 3, 4, 5 triangle. Relax. If we didn't know that, you could have just done this. You could have gone 30 squared plus 40 squared equals C squared. And you could have gone C equals the square root of 30 squared plus 40 squared. And that would have given you 50. Yeah, no, don't cry. Are we okay so far? All right, so here we go. We got our C. What is the look? This is a relationship. What is the relationship that connects A, B, and C together? The same. It's the same one. What is it called? Start with letter P. Say it out loud. Say it loud and proud. What is it? It's Pythagorean theorem, guys. We just no. It starts with P. We just did it right now. Pythagorean theorem. Here we go. A squared plus B squared equals C squared. Take a derivative. All right, guys. Focus. What's the derivative of A squared? 2A dA. No. dt. Plus, what's the derivative of B squared? Equals what's the derivative of C squared? Yay or nay? Yay. You can cancel out the 2's because now you can factor out a 2 on the left and cancel, you know, if you factor out a 2 on the left, you can also divide by 2 and everything, the 2's will cancel out. So you can cancel out the 2's. And now, let's see, I can isolate dc dt or I can just plug in and then start solving, which is what I like to do. So here we go. 30 times dA dt, which is 8, plus 40 times dB dt, which is negative 2, equals 50 times dc dt. So let's see, 30 times 8, 3 times 8, 8, 16, 24, so that's 240. Minus 80 equals 50 dc dt. 240 minus 80, what's that? 160. So I'm going to write it right here. 160 equals 50 dc dt. And then divide by 50. So dc dt equals 160 divided by 50, which I'm assuming is that number up there. dc dt equals, let's make sure, 160 divided by 50. 160. Yeah. 3.2 inches per second. Okay, now that we've done this, do you feel that we can tackle delta math now?
Can we still ask questions?
Yeah, of course. All right, let's tackle it. Beat it up. One of them is due today, the other one is due tomorrow.